Intro to energy. In our world, there are many incredible things that are occurring around ourselves, and sometimes we don't notice it. For example, in the night that have heavy rain and storms, there is lightning occurs. It created lots of sound and creates light. This is an example of transforming one form of energy to others. Lightning converts electrical energy into light, heat, and sound energy. Sometimes we didn't notice that lightning also creates heat because we can hear the sound and see the lightning form.
Definition of energy. Energy is the capacity of doing work in which it could occur in potential, kinetic, thermal, electrical, and chemical forms. It has been stated that energy can neither be created nor destroyed. Energy is a scalar physical quantity that is associated with the state of one or more objects. It can also generally be defined as the potential to do work or produce heat. The main SI unit it is in joules, but can there be other units as well?
Laws of conservation of energy. It is the total energy of an isolated system that remains at a constant, as well as all energy is conserved.
Types of energy used in the experiment. The experiment involves the following energy, which are potential, kinetic, and elastic. Kinetic. Kinetic energy is a property of moving objects or particles and depends on the motion of the object as well as its mass. It is directly proportional to the mass of the object and to the square of its velocity. K equal to 1/2 mv to the power of 2. As an example of kinetic energy would be the Earth revolving around the Sun and molecules moving in space. All have kinetic energies.
Potential energy. Potential energy is stored energy that depends upon the relative position of various parts of the system. You have more potential energy when you're on the top of the stairs rather than when you're at the bottom. This is because the gravitational force from the Earth that pulls you down. The formula for potential energy depends on the force acting on the two objects. For the gravitational force, the formula is PE is equal to mgh, where m is the mass in kilograms, g is the acceleration due to gravity, 9.8 meters per second squared, at the surface of the Earth, and h is the height in meters. Notice that gravitational potential energy has the same units as kinetic energy, kilograms meters squared per second squared. In truth, all energy has the same units, kilograms meters squared per second squared.
Elastic energy. It occurs when objects are impermanently compressed, stretched, or generally deformed in any manner. In this case, the spring. It is equal to the work done to stretch the spring, which depends upon the spring constant known as K, as well as the distance stretched. This energy can be used in many ways since the spring can remain in its compressed or stretched state for extended period of time without dissipating energy. Other examples of elastic potential energy are an archer's stretch bow and a bouncy ball compressed at the moment it bounces off a brick wall. Next is the elastic potential formula. Elastic potential energy equal to 1/2 times the spring constant times the extension to the power of 2.
Okay, so now let's consider an ordinary experiment about conserving energy with a car moving down on an inclined plane. How could work and energy be utilized in the motion of the car, with the total mechanical energy, which is like potential energy and kinetic energy of the car, be altered in the process of rolling down the inclined plane? Or would the total mechanical energy of the car merely be conserved?